Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you for your patience today. It's Jim Miller here with this month's SLA Competitive Intelligence Division webinar. And today we're going to present to you Peter Grimm, who's presenting with how technology is defining the next generation of CI. Just going to give you a bit of background on Peter. Peter is a graduate of the U.S. Naval Academy with experiences ranging from clandestine support for Navy SEALs to authoring intelligence featured in the President's daily briefing. And as CEO of Cipher, Peter leverages his national security and corporate strategy experiences and with the latest AI and natural language processing technologies to help clients better understand their competitors and markets. And Peter this is one of many presentations that he's presented for SLA CID. So Peter, I thank you again for your presentation today, and let you take it away. Thanks.
Great, thanks so much, Jim, and thank you everybody for joining us today. I apologize for the short technical delay there at the beginning. So let me just dive right in here since we're running a couple minutes behind. See if I can get my slides to work. There we go. So as Jim mentioned in his very kind introduction, I started off my career in the Navy, did some work with the Navy SEALs. It was really more of a bus driver for them, is probably the best way to put it. I was in charge of a small boat unit that was responsible for taking them to where they needed to go, dropping them off, and then picking them up after school, so to speak. From there, I went into the government as a civilian intelligence analyst and worked on counterterrorism issues. I spent quite a bit of time in Iraq in the midst of that conflict a number of years ago. And after that, I went on to Deloitte, which was a bit of a transition, as you might imagine, going from government counterterrorism into sort of corporate strategy, but have really enjoyed that world ever since. And so what we'll talk a little bit about today is kind of a blend of those two worlds. So some of the experiences and insights that I picked up in the government world and how they apply to doing commercial competitive intelligence and strategy development. So let's talk a little bit about AI. And what we're going to focus on today is sort of a couple main themes. One is, how AI is transforming business, how it's transforming certain industries, and then specifically how it's transforming the role of an intelligence analyst or a knowledge professional. And so if you look at some of the things that are out there in terms of predictions about how AI is going to change the knowledge workers world, I really like this Gartner report that came out a bit ago. They talk about how 1 in 5 workers by 2022 will rely on AI to do their job. And so you hear a lot about how AI is going to replace workers and displace certain job functions, and I think that's true. But mostly the predictions are, and I think they're accurate, is that AI is really expected to replace sort of low-level routine work where there are sort of processes that are repetitive that can be automated in a more efficient way and those types of things. But, even higher-level knowledge workers, like many of you on the call today, are going to see AI play a bigger and bigger role in your worlds over the next few years. So instead of replacing these knowledge workers, I think that the consensus is that AI is more or less going to be there to assist you. And the combination of human and machine will do the job of intelligence and analysts or insight development or strategy development more effectively than either could do it working alone. So it's really about how we harness these new capabilities in the world of AI and synthesis with things that are uniquely human. An interesting prediction is that AI is poised to create more jobs than it eliminates over time. So let's talk a little bit about how AI is transforming industries, and we've seen the impact of AI across a variety of verticals. We certainly see it in our day-to-day work with our clients. But let's talk a little bit about healthcare, some of the kind of key applications that we see at AI. Obviously, healthcare, like many industries, but healthcare in particular, is a very data-intensive vertical. Lots of data about patients in particular, medical records. Think about the advent of electronic medical records and so forth. But also going beyond just mining that vast amount of big data in terms of patient data, we're also seeing things like AI-driven diagnostics, AI assistance in the development of treatment plans, AI assistance in the course of actually doing procedures, as well as around drug discovery. And obviously, IBM Watson is probably the best known instance of AI being applied to some of these really, really pressing societal problems. And the impacts we're seeing from that, obviously it focuses around cost and time savings, and then the key one there is better patient outcomes. So how can we leverage AI to help doctors treat patients more effectively? When you look at financial services, you're seeing AI even in your day-to-day, I imagine, as consumers in your personal finance world. The advent of things like AI-enabled chatbots. So if you go to your bank's website, chances are that you're going to be interacting with one or more types of AI before you speak to a human being. They're using it for things like predicting market behavior, for doing document analysis. Obviously, there's quite a bit of data involved in financial services as well. And again, in addition to kind of the key things around cost and time savings, competitive advantages, but it's also a focus in that vertical is really around customer service, like we talked about with the chatbots and so forth. We're seeing it in education with automated teaching assistants, generating content and curriculum, doing personalized training for kind of ongoing continuing education. Manufacturing, you hear a lot about the IoT in the manufacturing world and things like intelligent factories, but it's also being employed for things like failure prediction, component failure prediction, quality assurance. Lots of focus in the manufacturing world, primarily around operational efficiencies and improved quality. Same thing in transportation. Lots of data, more and more data is being produced in the world of transportation when you have things like smart cities coming online. You probably use a version of AI every day in one form or another on your smartphone as you're driving around with your GPS. And then obviously, the big trend around autonomy. So not just autonomous vehicles, but trains, ships, all sorts of different modalities. Again, focusing on, efficiency and safety. Let's talk specifically for a second around the insurance industry. We happen to do quite a bit of work in that vertical. Really insurance is starting to see the initial impacts of AI, but it's really going to increase dramatically over the next 20 years, I think is the consensus prediction. There's a couple main trends here going on in insurance in particular. Connected devices are just producing, petabytes and exabytes of data about consumers and sort of consumer behavior and being able to predict, do more sort of real-time service delivery and more predictive modeling of risk and actuarial problems and those sorts of things. Obviously, we talked a little bit about autonomy and the increasing presence of physical robots, so things like obviously autonomous vehicles, but farming equipment, surgical robots, drones, all of these things are shifting risk pools, rather, in the insurance industry and changing customer expectations around them. The open source data and sort of these data ecosystems where we're seeing the increasing use of kind of standardized data formats that allow different users and processors of this data to all leverage big, enormous pools of big data across many private and public entities, and then cognitive technologies where we talk about the ability for a machine to do things like decomposition and inference. And we'll talk a little bit more about what that means and how it'll have an impact on this audience in just a second. One thing I think that's really interesting when you talk about insurance and certainly catches the attention of professionals in that vertical is, KPMG is predicting that the decrease in accident frequency that will come from autonomous vehicles over the next 25 years could shrink the U.S. personal auto insurance premiums value by about 60%, which is just a huge number when you think about a disruptive trend in an industry. So let's take a couple of minutes now and talk specifically about, what does this mean for me as an intelligence professional or somebody that's responsible for developing insights within a business? A couple of key things. So let's talk first about kind of the traditional intelligence cycle. And this, was developed in the in the industrial age, very 20th century sort of Cold War view of how intelligence was done. You have this cycle that anybody that's been in this world for any period of time has probably seen or been exposed to. You start with sort of planning your intelligence process with a series of key intelligence topics or key intelligence questions. In the government, we would have called those PIRs, or priority intelligence requirements. You develop a collection plan in terms of, where does this information that I need to answer these questions live? How am I going to go about collecting it? How do I, whether it's various databases that I need access to, how can I use things like Google Alerts, or maybe there's SEO tools that I might want to look at my competitors through. What are all those sources, and how am I going to access the information? Then there's generally a period of processing where I need to do some work around just organizing all of this massive amount of information that I've collected so that I can find things and make relationships clearer within these big data sets. Then I finally get to do some analysis and actually think about what it all means from a strategic perspective for my business. Then once I've come to some analytical conclusions, I can put them into a very pretty report or a PowerPoint or a document of some sort or a presentation and disseminate that out to the decision makers within my organization that need those insights. So with AI, this is changing considerably. And the first thing, if we think about this is from sort of a systems perspective, is the inputs. So it's no longer possible now, there's so much data being generated that it's no longer possible or even really necessary for a human to collect all of this stuff and try to collate and package and store all of the information that the analyst needs. The volume is just too great. So what the prediction is, and we're seeing this more and more, is that analysts will increasingly become sort of distanced from the data and have a set of tools and automation in between the analyst and the data that is doing some of the more sort of rote tasks of collating and indexing and organizing all this information, or processing it in various ways to make it more accessible to the human analyst before the analyst ever sees any of this information. The key thing here, we'll talk a lot more about this in the following slides, but humans are still going to be required to sort of generate hypotheses, but then they can leverage very powerful AI and machine learning to test them against vast bodies of information that just wouldn't have been possible, a few years ago. And then how do the outputs change? Well, instead of sort of finished intelligence products in the traditional sense that we think of them, like I talked about, whether it's a presentation or a report or a PowerPoint of some form or fashion, increasingly these analysts will be shifting to sort of curating a vast knowledge base that contains answers that customers can access and interrogate kind of at their leisure. Again, we'll talk a little bit more about what that means more specifically here in just a second. So just another way to think about this, again, going back to the traditional view of the role of an analyst, of an intelligence analyst, or not really a knowledge worker of any sort, the sort of legacy model here would be that this analyst is responsible as a human being for going out and collecting all of this information. They're going to then organize it into some sort of file store. And, I can even remember the days when this was literally a file cabinet. Increasingly, that's living, in computer storage. But then, they would take all of this information, they would do use the power of their highly trained human brains to do this analysis and produce a finished product for the customer. And the key thing here was that the analyst was at the center of all this information flow. So it really valued for what was in this analyst's head and their ability to communicate that to a customer within the organization who needs insights. Now, sort of the AI-enabled professional or the AI-enabled analyst, there's a couple key differences here. We talked about the layer of tools or the layer of automation that resides between the analyst and the information now. So we've got, the ability to automate the collection of a lot of this information in a very seamless way where a human doesn't even have to touch it. In fact, we can't just only collect it. These tools enable us to do quite a bit of very sophisticated processing of information now before a human being is going to see this information. So if you think about things like natural language processing or semantic tagging or those types of capabilities that organize information automatically, even so far as to, identify conceptual themes that are contained in that information, or correlations or relationships within various data sets, and then presents sort of that first layer of analysis to the analyst. So instead of the analyst having to make all of those connections and do all the indexing and correlating themselves, machines can now do quite a bit of that on their own. So the reality is now, instead of being the center of this flow, the analyst becomes more of a partner with their customers. And so the analyst is now, it's not important, it's not as important for the analyst to be the sort of keeper of all knowledge. They're going to be valued less for what they know and more for how they think. So, it's much more of kind of a consultative role that the analyst will be taking here in terms of helping the customer define the problem they're trying to solve, having the expertise and the experience to be able to bring to bear the appropriate tools, the appropriate analytics to get to the insight the customer is looking for, and then facilitating the process, whether the customer is interacting with the tools directly or if the analyst is helping them. It's a much different role than it was where you had the analyst who was, again, kind of the keeper of all knowledge. So just to kind of recap here, future analysts are going to be, much more relied upon for their ability to think about and model these systems. Again, I think back to kind of Albert Einstein and his famous quote that if you had, I'm paraphrasing here, but I think he said something to the effect of if you had 5 minutes to save the world, he'd spend 4 of those minutes defining the problem, right? And that's really what I want you to think of the kind of future analyst role. Much more on kind of creative faculties. How do I imagine and hypothesize? How do I communicate more effectively? The analytical graph, that sort of grunt work of collecting and reading and remembering things is, largely outsourced to machines. The breadth of experience will be much more important than the depth of experience. And this one's a key, kind of coming out of the government space. And I think it's certainly true in a lot of industries too, where the intelligence or the insight professional in the past was really valued for being a subject matter expertise. They knew the competitors inside out. They knew, where all of the competitive plants were. They understood the regulatory environment. They know, how certain trends in market data are playing out because they had all that information in their head. But the reality is now, that is less valuable because machines can do a lot of that for us. So it's much more about the breadth of experience in terms of the knowledge of how do I help my internal stakeholders best leverage technology to get to the insights they're after. And then again, the kind of future analysts' interaction with information is going to be driven by salience. So it's really about defining those novel problems and having the understanding of what sources of data and what tools and analytics can be brought to bear to get to the most salient insights for that customer. So let's talk a little bit about the difference between artificial and human intelligence. There's some key differences, and I want to start with kind of a basic discussions of the 4 kinds of logic. So if you think about the way human beings think, the most sort of basic or certainly the most logical way in which we think is called deductive reasoning. Basically, you have 2 or more observations that logically lead to a single correct conclusion. So things as simple as, if A equals 1 and B equals 2, then the only correct answer for A plus B is that A plus B equals 3. Very simple, very linear, very logical. Inductive reasoning is a little bit different. This used to be sort of thought of as the last domain of human beings versus AI, but I think with the advent of machine learning and other forms of AI, we're seeing increasingly that machines are getting better at this. So this is where we're going to take a series of observations that lead to a likely explanation, but not with total certainty, right? So if you think about, if I say to myself, I've seen a lot of swans in my life, and every one I've ever seen is white. So probably all swans in the whole world are white. There's some logic to that, and I've made an inductive inference based on, a whole series of observations that all swans in the world are white. But it leaves the possibility that that might not be true because I have an incomplete set of observations. You think about how machine learning works, it's getting very good at this type of thinking, finding patterns in vast masses of data without being told what it's looking for in a lot of cases, right? So if you give a computer a massive set of data and it identifies this pattern, it may not know what that means, but the next time it sees something that fits that pattern, it can draw some inferences about what that means. The next one I want to talk briefly about is deductive inference. So think about this kind of like reverse logic. So if we have a hypothesis, this would be, kind of a very human way of thinking about, well, if this hypothesis is true, what other conditions would need to be met? So if every swan is white, what else has to be true? Well, there are ways we can test that scientifically. We can go out and collect, a larger sample size of swans, and if there are no, other colors in that sample, we get a higher confidence in our hypothesis. But that's really, deductive inference is really how we generate as human beings, how we generate hypotheses. But there's another way called abductive reasoning, and this is sort of, the best way to describe this is kind of human intuition, right? The educated guess that sometimes we can't even really articulate why we think something might be true. We sort of have a hunch, right? So we jump to the most likely explanation based on experience or just plain intuition. Things like, if I walk into a room and the floor is covered with torn up papers, and I also know, based on another observation, that my dog was alone in this room most of the day, I could jump to a conclusion there that it was probably my dog who ripped up the papers. But there are lots of other things that could explain that, right? And there's not necessarily a logical jump from one to the other than just based on the fact that I know my dog and I have some experience with that dog. But it could be that somebody else came into the room during the day and ripped up a bunch of papers to frame the dog or whatever it might be. Hopefully you kind of get the gist of what I mean there with the educated guess. So let's talk about how computers handle these different types of reasonings. Deductive is pretty simple, right? We've had basic calculators for nearly 100 years that could do deductive reasoning in terms of, A plus B equals 3, that kind of thing. Where we're really seeing the movement now, in my view, and again, I'm not an AI expert by any stretch, but how I've seen this in applications in our daily work with our clients and certainly within the national security world, this inductive reasoning is really where the biggest strides in terms of the applications of AI are being made today. So taking a whole series of observations and think about big data, a massive set of observations of the world, and then the ability for a machine to train itself based on patterns and looking through these big data sets to identify a likely explanation or a likely insight. Can't do it with 100% certainty, but they can get, they can make some inferences from patterns and data. They're making some progress too in terms of being able to generate hypotheses, but it's not to the point where we could use it for the purposes we'll talk about in just a minute. And again, I'm not an expert in this field, but I have yet to see a computer that can make an educated guess or rely on sort of that purely human intuition. So let's talk about why that's important from a strategy development or an intelligence development process. And this is a sort of rubric that I was actually taught at Deloitte by a gentleman named Fred Pollard, and if you have an opportunity to look him up, I highly encourage it. But he talks about sort of how we solve problems and the different ways that human beings can work from, if you look at the bottom left of this sort of graph area here, from what he calls complexity up to the top right corner, which is conviction. So our journey here is to get from the bottom left to the top right. If you look sort of horizontally across the middle of the screen there, you'll see a small line. So if we think about below that line as being inputs to our process, so data gathering, collection, organization, those types of things. And then above that line being outputs. So finished insights or finished intelligence products or recommendations or whatever the output of our effort might be. So the first route from complexity to conviction that Fred talks about is called the expert route. And if you think about things like professions like IT consultants, think about somebody who's going to do an implementation of SAP at a large enterprise. We've probably done that a number of times before, and they understand what conviction looks like. They've done it before. They know what done looks like. They know what success looks like. So it's relatively easy for them to lay out a work plan. Now, we'll go directly linearly, right? There'll be some milestones and some gate checks and so forth, and there might be minor setbacks here and there, or unforeseen events to push them slightly off schedule. But more or less, they're going to go linearly from complexity to conviction. They have a work plan. The next route is called the analytical route, and this is the one that we were all taught to use in school. And there's a number of professions that rely on it heavily or exclusively in some cases. So if we think about this, how were you taught to think in school, or especially if you went to something like law school, or if like me, or a history major? You spend a lot of time gathering information, reading, looking through case notes, looking through notes of discussions and so forth, gathering data. So we're going to spend a long time sort of in the bottom half of this graph in the inputs. And we're going to keep gathering data until hopefully we have this sort of aha moment where we get to certainty in the bottom right corner. And from there, it's very easy for us to go, well, we've collected all this data, we've analyzed it, and we found the answer, and we feel very strongly about it. So we go right up to conviction. Think about the professionals or the professions that use this type of thinking. And no offense to any of you on the line who fit into any of these molds, but this fits very well if you bill by the hour, right? So think about sort of lawyers and accountants and engineers and others that bill by the hour. They love to live in this data and eventually sort of get deductively to a conclusion or to an answer. Academics obviously do this too. This is how we were all taught to sort of do research and come to analytic conclusions. Now there's a third way, and this is called the creative route. So if you think about sort of a creative professional, when they're faced with a challenge where a client says, you know, let's say I need to build a new house. The first thing that architect is going to do is strive for some clarity. So when we're in the bottom left corner as an architect, we have basically infinite options in terms of what this house is going to look like, how many rooms it'll have, what the style will be, how many floors will it have. All of these sorts of options are on the table. So the first thing this architect is going to do is give his or her client some options. And they might say, you know, here are three kind of conceptual designs that we wanted you to look at. There's sort of an ultra-modern version, there's a more traditional version, and then maybe there's this one that's my own personal style. And you can, from there, get very quickly to clarity. And the client will say, I hate that ultra-modern thing. The traditional thing is okay, but I really like your particular personal style option. And so from there, now it's a matter of just details, right? And there's not a lot more data that needs to be collected. We sort of go right from clarity to conviction in terms of what the answer is going to be. Now there's a fourth route, and this is the way I was taught to think as an intelligence analyst. And so it's kind of a blend of number 2 and number 3. So if we're faced with an intelligence problem where there's tons of complexity, there's lots of uncertainty, there's not complete data to work with, there are lots of unknowns. Rather than trying to collect data until hopefully an answer appears to us, it can be really helpful, it's almost always very helpful to try and structure the problem with some options. Basically, this is, if you think about it, this is developing hypotheses. So if I'm a competitive intelligence professional and I've been asked to analyze, the competitive strategy of one of our largest competitors, knowing nothing else, and with having lots of uncertainty about what this, let's say they're a new entrant about whom we know very little, I can structure some options very quickly. I can develop a set of hypotheses. I can say, well, they probably have one of these 4 types of strategy, and then I can test against that. So that's where we start to dip back down into the inputs and validate it with data. But the advantage here is that I'm not going to boil the oceans in terms of data collection. I have a very specific set of hypotheses that I'm trying to test against. So it limits the scope and magnitude of the data with which I have to deal. So that is sort of how I was taught to think as an intelligence analyst, as a strategy consultant. It's also how, if you think about it, how doctors are taught to think about it, particularly emergency doctors. So if you present to the emergency room and you say to the doctor that, my stomach hurts, I have a headache, and my fever is 103, and I have this weird back pain. That's 4 pieces of data you've now given the doctor. From that, they're going to sort of inductively draw some inferences and develop some hypotheses. And they're going to say, given that combination of symptoms, you most likely have one of these 4 conditions or diagnoses. So they've structured the problem immediately with options. From there, what does the doctor do? They run tests, right? They're going to try to prove or disprove their various hypotheses. So that's where they go back into sort of validating with data to get back to conviction in their diagnosis. So I'll come back to that concept in just a minute, but for a minute, let me talk about the differences between human and artificial intelligence. When I started to research this almost a year ago at this point, I was struck by how salient some of the initial work that was done on this has turned out to be, or how prescient might be a better word. So what I'm showing you here is from a paper that was written by a guy named Feigh in 1951, when the first sort of conceptualization of what artificial intelligence and the potential for computers to think like humans would mean. And he came up with this thing called the fits list. Basically, there are things that, in his view, humans are better at, and there are things that our machines are better at. Now, this is changing, but to give you a sense of how long people have been thinking about this was 1951, as I said. So he said artificial intelligence is going to be better at automating repetitive and time-consuming tasks. That's certainly true. The ability to respond quickly and precisely to control signals, apply great force smoothly and precisely, the ability to store vast amounts of information and then erase it completely, which if you think about it, humans cannot do anywhere near as effectively as computers. The ability to do many different things simultaneously, and the ability to reason deductively. So, the ability to serve as that sort of calculator we talked about. Fitz also said that humans were better at the ability to learn from limited data and solve problems with sort of limited computational resources. So kind of that notion of human intuition or the ability to draw inferences from incomplete data. Humans are better at dealing with uncertainty by improvising. They're better at the ability to extract semantic information from visual scenes. I think there are lots of folks that would argue that machines are getting much better at that. And then the ability to acquire knowledge from the outside world and build internal models. Again, there are progress on some of these, but things that since 1951 have been considered sort of, very, very much innately human. The last of these is the ability to reason inductively and exercise judgment. Now, as we mentioned when we talked about the logic, machines are getting better at inductive reasoning, but really what Fitz was talking about when you go read the work is more of that sort of intuition, the intuitive thinking, the ability to, with a very incomplete data set based on sort of my own experience or my own hunch, develop a set of hypotheses. Machines are still not there. And AI is certainly coming. We've heard a lot of the hype, but it's not moving as fast as you might think. There are some serious challenges remaining. The Watson example is a good one. I think when you look at how much marketing was put behind Watson and what the promise that was communicated about Watson was communicated into the market, the expectations were set pretty high. And there are some innate challenges even with the most advanced AI. So things like incomplete data. This is just last year. And unless machines have, you could have the most advanced sort of machine learning algorithms, but unless they have a vast set of data on which to draw their inferences using their machine learning, they tend to stumble rather. And if you look at that last bullet there, I think that's a good example. So if there's rare cancers or recurring cancers, there's not a lot of data in existence about those particular conditions, and it's difficult for Watson to draw those inferences with incomplete data, as we talked about. The other thing is that somebody has to train these machines, and Watson has human trainers that were focused on ensuring that the most recent studies were included in the data set that Watson was analyzing and so forth, but they're humans, and there were delays. And so, often the inferences that Watson would draw, particularly in these rare cancers, would be inaccurate because the research had progressed so quickly beyond the data set that Watson had to work with. So, I think the bottom line here is, and I've talked to folks from IBM about this, they obviously have a slightly different view, but the reality is I think they would concede to you that, it's not there yet. The potential is there, but there's a lot of things to overcome, and it's not going to be in the next, year or two that this is on the scene and we have machines that can think like humans. So let me take you back to that strategic mindset slide very briefly. We talked about sort of the strategic thinking path from complexity to cognition. When you put that in the context of what does that mean to me as an intelligence analyst, and how is AI going to impact this? Really, hypothesis generation that we talked about in the first sort of jump from complexity to clarity is still the domain of the human, right? There are not machines yet that are capable of reliably generating hypotheses that we can then go test. They're very good, on the other hand, at helping us test those hypotheses, at digging down into the data and living in the inputs and finding relevant information that can either help us prove or disprove a hypothesis. So fundamentally, I think that's what this is about. And I think, as intelligence professionals, as information professionals, the key to success in the next 20 years of our profession is going to be understanding how these tools work, understanding when and how and in what circumstances to apply which tool, and the technical capacity to be able to help our internal stakeholders do that effectively. But that human intuition of, coming up with the idea that it could be one of these three things and we should go test them, I think is going for the foreseeable future, at any rate, to remain the domain of professionals like you guys. So again, it's not that AI is going to replace information professionals at all. I think the job's going to change substantially over the next few years, and there'll be skill adjustments and skill set changes and training required in a lot of cases for folks to make this transition successfully. But the reality is, I think that the role of the human in using that intuitive ability to generate hypotheses and then knowing how to use machines effectively to test them is going to be the key to success over the next few years. Just a very quick anecdote from the national security world. I've been out of that world for quite some time at this point, but even when I was in it, there was just massive sums of money being spent, particularly right after 9/11, by the U.S. government on technology that was, theoretically held the promise to replace these armies of intelligence analysts that were costing so much money. Hundreds of millions of dollars, in some cases billions, spent on these tools. But the lesson we learned, and I learned personally, both myself and my own practice of intelligence analysis, and also in training younger, more junior analysts, was even the most sophisticated network analysis and sentiment analysis and social media analysis and graph theory and all these sorts of tools that were made available to us in those days were not worth a dime unless the analysts understood what that tool was doing and could develop hypotheses that they could then use the tool effectively to test. And so, fundamentally, my thought here is that you can't do this, and if you're not familiar with Palantir, it is probably the largest, the most, certainly had the most money spent on it in terms of intelligence analysis tools. It's a very sophisticated network analysis tool. You cannot use that tool effectively unless you've learned to do that process manually and you understand how to evaluate the credibility of information from different sources and how to understand relationships between data and how to develop your own hypotheses to go test those hypotheses. We're running a little bit late here with the late start. I'll just leave you with a quick quote from Garry Kasparov. If you're not familiar with him, famous Russian chess grandmaster, who actually was the first human grandmaster to be defeated by a computer. And he says, you know, when a machine makes a decision, it's using computation to go all the way down. But choice is human, because in order for us to make the right choice, we have to understand what matters and why. And I just thought that's a great way to kind of sum up the difference between, you know, the way humans think. The promise of AI is great. I think it's going to transform the way we do our jobs, but it's in no way do I think it's going to replace us. So hopefully that's been helpful, and we'll leave hopefully here a little bit of time at the end in case anybody has any questions. Jim, does that work for you?
Perfect. That's great. Thanks, Peter. This is excellent. I mean, this has been an excellent presentation, and certainly AI is going to play a significant role, and not that it's going to take away the human role. It's just changing the role that the humans play, and I think this is great in the sense of sort of the context of how we do intelligence analysis. We already have one question, so I'm just going to put this to you, Peter, is that and I think this is really important as well to look at, is that the EU recently came out with a set of guidelines on AI ethics, and I think that you know, this is an important component from the sort of human analysis standpoint. And so, what are your ideas around ethics and the importance of where ethics are going to be, in particular in light of these EU guidelines?
Yeah, it's a great question, and I'm by no means an expert on the ethics of AI. And in my view, in sort of the limited perspective through which I look at AI is focused on sort of how it's going to impact intelligence analysis. There are certainly all sorts of ethical questions around AI and autonomy, and you know, we do some work in the automotive and the technology space, and they talk about autonomous vehicles, and in the insurance space, it's a huge discussion around, you know, who is liable if an autonomous vehicle causes damage or strikes somebody, or God forbid kills somebody. Who's liable for that? Who's required to have insurance on these things? If you're using AI from a business standpoint or from a business strategy standpoint, there are sort of ethical with a small e questions that arise too. So, you know, if I'm going to make a recommendation as a strategy professional to executives in my company, and I base that recommendation on insights that were developed by AI, and those recommendations prove out to be incorrect, whose fault is that? Do I lose my job? Do we fire the AI vendor? There's all sorts of complexities there. So I would certainly not venture to try to answer all of those, but it's certainly a key area that should be you know, part of any discussion about this stuff. So I appreciate the question.
Yeah, that is an excellent question. I think that, you know, as society delve deeper and use the AI further and further into you know, various components, and as you mentioned, autonomous vehicles and smart cities you mentioned earlier, you know, there's a lot of ethical questions around even just the data collection and who owns the data, and who should have access to the data and for what uses. And you know, certainly there are a number of examples that we can point to. One most recently here is Sidewalk Labs here in Canada, where they're creating a sort of Alphabet is creating a smart city or section of Toronto, and who's going to own the data and how they use that through AI to provide services to people. And so I think that the ethics of that data ownership is going to be fairly important too. So we have some more time, so if you have some questions, please feel free to ask them in the chat box there. I just had one quick question for you, Peter, which was around sort of the analytical tools that would be used if you're using AI. You know, the AI tools are being developed, but do you think that any of the other analysis methods will sort of become less important, or do you think that it's just going to be applied, or they'll be applied in different ways?
Yeah, so I mean, I can speak specifically to the competitive intelligence market space in which we operate. You know, and AI is having a number of impacts. I think fundamentally, the past few years and sort of the period we're in right now has been focused on leveraging AI to remove those tasks of intelligence analysis that do not require a human brain. And what I mean by that are primarily the tasks of collecting information and more of organizing the information. And now, in the past couple of years, really a much higher focus on some pre-processing of that information to develop sort of this first level of insights. So, you know, we deal with quite a bit of text-based content in the world of competitive and market intelligence, and the advent of things like natural language processing, sentiment analysis, of semantic tagging, semantic analytics. Those text-based technologies have really, in a lot of ways, freed the analyst from having to spend a lot of time in the data, identifying patterns or identifying relationships between entities or identifying and characterizing entities, the sort of basic tasks of analysis that serve as the foundation for generating real insights. Today, there are tools on the market. Certainly our tool is one of them. Our generous sponsors, Aurora, have one as well. There's a couple others that specialize in that type of analysis that really is designed to free the human analyst from those sorts of very time-consuming, low-value tasks and allow them to focus more and more of their time on the higher-value strategic insight generation. You know, to the extent that changes over time, we'll have to wait and see. You know, at this point, I have not seen, and granted, you know, I've not seen every piece of AI that's out there, but in that which I've been exposed to, I have not seen anything that comes close to being, in my mind, trustworthy of generating a set of hypotheses that we could then go test in any context of strategy development or intelligence generation or anything like that. So that's kind of where I think we are now. My sense is that's the trend that we'll see continue, at least over the foreseeable future. It certainly could be that a little bit farther down the road we have completely autonomous intelligence analysts, although I would frankly be very surprised if we get to that point.
Excellent. I mean, this has been a great presentation, and I think this is one that certainly, you know, be looking to further expand upon, as well as the field continues to grow. And certainly, you know, I think that if you look at the pieces around hypothesis development, and that's not really going to change, but in fact, the tools that we do use and what we have to base hypothesis on will certainly significantly change. And again, that just goes to the sort of whole idea of context around what we're actually trying to achieve. So I think that's fairly important. So this has been excellent, and I want everyone to stay tuned. We're going to be having our conference preview webinar coming up in May. So we'll be posting some information around that, and we'll be talking about all of the presentations and events that will be happening at the SLA conference this year in June in Cleveland, Ohio. If you're able to attend that, that's great. And as always, we the CI division have an excellent track record of putting on excellent events. The Breakfast with the CI Fellows. We have a new Intel mission this year. It's a new event that will be happening, and as well as our always insightful State of CI presentation that we have, and we'll give you some highlights and previews of that in the next webinar coming up. And also, I'd like to thank our SLA CID sponsor, Rory WC. And as Peter mentioned, they have the tool software platform, the First Light software platform, which gives you flexibility as you collect instance data from hundreds of sources, and there's hundreds, if not thousands, out there, and delivers critical insights for your organization. So if you want to look at take a demo of that, go to getfirstlight.com, and you can schedule a demo for the First Light software to look at what they're doing as far as competitive intelligence analysis. And so, Peter, I'd like to thank you for the webinar today, and hope everyone can join us next month for another SLA CID webinar. Thanks, Peter.
My pleasure. Thanks, everybody, for your time and attention. And just very quickly, if anybody would like a copy of the slides today, there's a link on the screen there where you should be able to get a copy of them. So thanks again for hosting, Joe.
Great. Thank you very much. Okay. Thanks. Bye-bye.